Today we'll take a look at the inverse of a matrix. We'll talk about how to find it. We'll talk about what it's used for. You might want to start with this idea. You know that in the world of constants, there's such a thing as a reciprocal. So for example, the number 3 has a reciprocal of 1/3, and if I multiply those two numbers together, I get back the number 1. Well, in the world of matrices, there's a very similar concept. Suppose you have a matrix A, and that matrix has to be a square matrix, right? This doesn't work for matrices that are not square matrices. The inverse of a matrix, you might label A inverse. So that would be the inverse of matrix A. If you multiply the matrix by its inverse, what you get back is not the number 1, because we're not dealing with scalars. What you get back is the identity matrix, which again is a square matrix of whatever size matrix A happens to be. Now, that assumes a big thing. That assumes that A has an inverse. So first of all, A has to be a square matrix. If A is invertible, meaning it has an inverse, then A inverse exists, and we have a name for it. If it's invertible, we call it non-singular. All right. Oddly enough, if A does not have an inverse, if it's non-invertible, then we call it singular. So it's sort of the opposite of what you might think. If it is invertible, if it does have an inverse, then we call it a non-singular matrix. If it's non-invertible, then we call it a singular matrix. All right, so how do we know what an inverse does, or whether a matrix is an inverse of another one? All right, let's take a look at two matrices. Here we've got matrix A, which is the matrix 3, 1, 5, 2, and we'll call matrix B 2, -1, -5, 3. And my question is B the inverse of A? Well, if I knew how to find the inverse, I could take the inverse of A and see if it matches up with B. But right now, let's take the two matrices and multiply them together and see if we get the identity matrix. So let's multiply A times B. All right, so what do we get when we multiply row 1 by column 1? Remember, we start with row 1 over here, column 1 over here. So 3 times 2 is 6. 1 times -5 is -5, so 6 minus 5 is 1. All right, go to row 1, column 2. You'll get -3 plus 3, which is 0. Okay, now do the second row. Do 5 times 2 is 10. 2 times -5 is -10. 10 minus 10 is 0. 5 times -1 is -5 plus 6 gives me 1. So A times B is the identity matrix. This is the identity matrix that's 2 by 2. What if I want to do B times A? Think that'll give me the same thing? Let's find out. Let's put matrix B first. 2, -1, -5, 3. And then we'll multiply that by matrix A, which is 3, 1, 5, 2. All right, let's go for it. 2 times 3 is 6, minus 5 is 1, so here we are. 2 minus 2 is 0. -15 plus 15 is 0, and -5 plus 6 is 1. Okay. So AB is equal to BA, and they both give me the identity matrix. Then yes, B is the inverse of matrix A. Could I go one step further and put this in more general terms? That if I take A times A inverse, that's the same as taking A inverse times A, and I end up with the identity matrix. So it turns out there are some cases where order of matrix multiplication doesn't matter, and this is one of them. All right, and you'll see a couple others as we get further on. So now here's the big question. How do I find the inverse? Well, let's work through a process that will eventually lead us to something easier. So I know that if I multiply a matrix by its inverse, I get back the identity matrix. So let's try that. Let's take the matrix 3, 1, 5, 2. That was our original matrix A up at the top, 3, 1, 5, 2. And I'm going to multiply it by a matrix that has 4 coordinates, and I don't know what they are. So I'm going to call them x1, x2, x sub 3, x sub 4. And I know if I multiply those two matrices together, I'll get the identity matrix. Okay, so I'm using matrix A to find A inverse. And if I look at it this way, this is A inverse, and this is the identity matrix. All right. From this, I can come up with 4 equations, right? A system of 4 equations. Let's multiply row 1 by column 1. So let's do 3 times x sub 1 plus 1 times x sub 3 equals what's in row 1, column 1 up top of matrix on the right-hand side. All right. Now let's do row 1 by column 2. When I do that, I'm going to get 3x sub 2 plus x sub 4 equals 0, because that's what's in row 1, column 2. All right, let's do the second row. I'm going to put the second one under here. 5 times x sub 1 plus 2 times x sub 3 equals 0. And down here, when I do row 2, column 2, I'll get 5 times x sub 2 plus 2 times x sub 4 is equal to 1. What does that give me? Well, now I can go through and I can solve each of these to find x1, x2, x3, and x4. All right, that's why I purposely put the 1s and 3s on one side, 2s and 4s on the other. All right, so what if I multiply the top row here by negative 2? Then I get negative 6x sub 1. I get negative 2 here. Negative 2 times 1 is negative 2. So now add them together, and this gives me negative 6 plus 5, so negative x sub 1. 2x sub 3 and negative 2x sub 3 go away. 0 plus negative 2 is negative 2. So yes, x sub 1 is 2. All right, substitute it back in. Let's see. 3 times 2 is 6. Here, I'll come over on the side here. 6 plus x sub 3 is equal to 1. X sub 3 must be 5. So as I start filling in the A inverse, what do I know so far? I know x1 and x3. X sub 1 is 2. X sub 3 is 5. Okay. Oh, sorry, negative 5. 6 minus 5 is 1. There we go. Okay. Now let's tackle the other side over here. Let's take this top row, let's say, and multiply it by negative 2 also. So I get negative 6, negative 2, and that's still 0. Negative 6 plus 5 is negative 1, so I get negative x sub 2 equals 1. So x sub 2 must be negative 1. So up in the top here, I can put a negative 1, and then the x sub 4 is the one that goes in the bottom. Well, if x sub 2 is negative 1, 3 times negative 1 plus x sub 4 is equal to 0. X sub 4 must be 3. Right? If you go back and look at the A inverse that we came up with, that is the inverse, right? If I scroll up, can I scroll up? Yep. 2, negative 1, negative 5, 3. That's what I came up with for the inverse. So if we wanted to find an inverse, we could do it that way. It wasn't a terrible process, except that we had to solve a couple of systems. One thing you might notice when you set these systems up is that we did the same process to solve both of them. I mean, literally, we multiplied the top row by negative 2 in both cases. Because when we got done multiplying out the system, they had the same set of coefficients, right? The odd ones, the x1 and x3, had coefficients of 3, 1, 5, 2. The other one also had 3, 1, 5, 2. The difference being what? The difference being that we had a 1 and a 0 in the first group and a 0 and a 1 in the second group. So why not come up with one giant matrix that has those same coefficients, and then we'll just drop the 1 zeros and 0 1s on the other side. So my original matrix was 3, 1, 5, 2. The identity matrix is 1, 0, 0, 1. Right? So this is matrix A. This is the identity matrix. My goal then is to see if I can turn this into a matrix that has the same number of rows and columns, except it has the identity matrix first and the other matrix second. So let's see if we can do that. First thing is, let's take the top row and, well, let's get rid of the 5 that's in the bottom left corner. I don't want to introduce fractions too early in here. So let's take 5 times row 1 minus 3 times row 2. Answer goes in row 2 because my goal is to get rid of the 5 that's down here. So if I do that, I'll do a little scratch work on the side over here. The top row becomes 5 times 3 is 15, so 15, 5, 5, 0. The bottom row, if I multiply 5 by negative 3, I get negative 15. 2 times negative 3 is negative 6. That's a 0. That's a negative 3. All right, so in the first step here, row 1 remains exactly the same. 3, 1, 1, 0. The bottom row, add these two together. That becomes a 0. 5 minus 6 is negative 1. 5 plus 0 is 5. 0 plus negative 3 is negative 3. All right. Now, I'd like to get the negative 1 here to become a positive 1. So let's multiply the bottom row by negative 1. While I'm doing that, I'm going to take the top row and divide it by 3. So I get 1, 1/3, 1/3, 0, 0, 1, negative 5, positive 3. All right, I'm getting there, except that I have a 1/3 up here that I don't want. So let's do another row operation. Let's take negative 3 times row 1 plus row 2. Answer goes in row 1, because remember, I'm trying to turn that into a 0. All right, so what are my numbers? If I do negative 3 row 1, all right, so I'm back to where I was before. Negative 3, negative 1, negative 1, 0. The second row is 0, 1, negative 5, 3. If I add them together, my new row 1 is going to be negative 3, 0, negative 6, 3. Okay. So my row 1 is negative 3, 0, negative 6, 3. My bottom row is 0, 1, negative 5, 3. And that's good, because all I have to do is divide the top row by negative 3 again. So yes, I could have kept them as integers until the end and then divided it, and I would have saved myself about 2 steps. All right, so divide the top row by negative 3 and put the answer back in row 1. So I get 1, 0, 2, negative 1, and the bottom row remains the same, 0, 1, negative 5, 3. Okay. Is this the answer that we got before? Should be, except now this is the identity matrix, and that's A inverse. So that's one way to find the inverse. Start with the original coefficient matrix on the left side, the identity matrix on the right side, and then row reduce your way through until you come up with the identity matrix on the left side and the inverse on the right side. Now, this is one way to find the inverse. There's other ways to find the inverse, and we'll tackle those as we go further along. Let's do an example with a 3 by 3, and then I think I'm going to split this video into a second part because it's starting to get a little bit long already. All right, let's take a look at finding the inverse of a 3 by 3. As you might imagine, it's going to take a few more steps because we have more entries. So inverse of a 3 by 3. Now, this is one that you probably wouldn't want to do by doing it the original way that I did it, where I put the 4 variables in it, because otherwise you're going to need 9 equations, and we don't want to do that. So here's the matrix that I want to find the inverse of. My matrix goes 1, 2, 3, 2, 5, 3, 1, 0, 8. All right, so that's A. My goal is to find A inverse. So I set up a matrix that has 6 columns. I put matrix A on this side, and I put the identity matrix on the other side, and then my goal is to row reduce until I get the identity matrix on the left side and A inverse on the right side. All right, let's do it. Let's see if this will all fit. So my matrix goes 1, 2, 3, 2, 5, 3, 1, 0, 8. Then on the right side, I put the identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, let's see if we can do more than one thing at a time so we don't have to write this a lot. What do I need to do? If I take row 1 minus row 3, put the answer in row 3, that'll get rid of that 1 that's down the bottom. All right, if I do negative 2 times row 1 plus row 2, answer goes in row 2. That'll get rid of the 2 that's in the first column. Good. So what's my first set of numbers? The first row remains the same, right? Nobody's talking about changing that first row yet. 1, 2, 3, 1, 0, 0. If I do row 1 minus row 3, 1 minus 1 is 0. 2 minus 0 is 2. 3 minus 8 is negative 5. And now the other side has to be done too, right? 1 minus 0 is 1, 0, and then 0 minus 1 is negative 1. I realize I'm writing on a slant here. And then the second time I knew this, I need to change the top row to be multiplied by negative 2. So 1 times negative 2 is negative 2. That becomes a negative 4. 3 times negative 2 is negative 6. 1 times negative 2 is negative 2. 0, 0. So now combine these two rows together. That's your new row 2. 2 minus 2 is 0. 5 minus 4 is 1. Negative 3. Negative 2. 1 plus 0 is 1. 0 plus 0 is 0. All right. So now things are moving along. I've got zeros under the first column. And now my goal is to get rid of the 2 that's over here. Well, that doesn't look bad at all. If I take row 1 minus row 3, answer goes in row 3, what's my last row going to look like? 1 minus 0 is... Well, no, let's not do it that way, because then we'll end up with an answer back where I don't want one. So instead, let's operate on row 2. So if let's get rid of this. Let's take row 2 and do negative 2 times row 2 plus row 3. Answer goes in row 3. All right. So negative 2 times row 2 is going to give me 0, negative 2, positive 6, positive 4, negative 2, 0. And I'm going to add that to 0, 2, negative 5, 1, 0, negative 1. All right. Let's write out what I have. Top row remains the same. 1, 2, 3, 1, 0, 0. Second row, 0, 1, negative 3, negative 2, 1, 0. Third row now, add up what I got here. That becomes a 0. That becomes a 0. So I got 0, 0. 6 plus negative 5 is 1. 4 plus 1 is 5. Negative 2, negative 1. All right. So we're getting somewhere. We now have 1s down the diagonal. We have 0s in the bottom left corner. Now our goal is to work our way up and get rid of the couple of 3s, the 3 and the negative 3 that's above the 1. So in this case then, let's take a combination of row 3 and add it. So let's take 3 times row 3 plus row 2. Answer goes in row 2. And then let's take negative 3 row 3 plus row 2. Oh, plus row 1. Answer goes in row 1. All right, let's try that. 3 times row 3 will make this a 3, a 15, a negative 6, and a negative 3. Okay, so let's take that and add it to row 2, put the answer in row 2. So this time it's the bottom row that stays the same. 0, 0, 1, 5, negative 2, negative 1. Okay, take those numbers here, add them to the row above, answer goes in row 2. So 0 plus 1 is 0, 0 plus 1 is 1, 3 plus negative 3 is 0, 15 plus a negative 2 is 13, negative 6 plus 1 is negative 5, and negative 3 plus 0 is negative 3. All right. Now, if I do negative 3 row 3, that just changes the signs. So negative, negative, positive, positive. We're going to add these numbers to row 1. Answer goes in row 1. Well, the first two remain the same, right? The first two are a 1 and a 2 because I'm adding zeros there. Negative 3 plus 3 is 0, exactly what we want. Negative 15 plus 1 is negative 14. Positive 6, positive 3. All right, almost there. Because now the only thing that's left is that 2 over there. So let's be careful not to reintroduce numbers that we had already gotten rid of. So in this case, let's do a combination with row 2. Okay, so if I take negative 2 row 2 plus row 1, answer goes in row 1. So let's try it. This will give me a 0, negative 2, 0, negative 26, positive 10, positive 6, right? So double and change the sign of each of these, and answer goes in row 1. So 1 plus 0 is 1, 0, 0. Negative 14 minus 26 is negative 40. Positive 16, positive 9. Okay. Second row, 0, 1, 0, 13, negative 5, negative 3, and 0, 0, 1, 5, negative 2, negative 1. All right. After all that work, my inverse turns out to be all integers. How nice is that? Will it always work out that way? Probably not. So negative 40, 16, 9 goes across the top, 13, negative 5, negative 3, 5, negative 2, negative 1. That's A inverse. If you want, you can take the original matrix A, multiply it by that inverse, and you should get the 3 by 3 identity matrix. All right, hang on to that matrix and its inverse because you're going to see that again in the next video, but I'm going to split it. You can take a break, come back for the second part of section 2-3 in a minute.